So back to our example from example 1, the sampling distribution of the sample mean of bagel masses. In the last video, we looked at part A, and we'll move on to part B. But as we do part B, remember that this was dealing with masses of bagels at this bagel shop. They're approximately normally distributed with a mean of 120 grams and a standard deviation of 22 grams. And in part A, we calculated the mean of the sampling distribution, and we calculated the standard deviation of this sampling distribution using these formulas. In part B, it says, what is the probability that a random sample of 16 bagels results in a sample mean of less than 112 grams? We're trying to find the probability that the sample mean is less than 112. And as we go through this, keep in mind that these techniques are going to be all the same as what you did in Chapter 7. You're still going to use, this is a normal distribution, so to find probabilities on a normal distribution, you can still use the same calculator methods and the same table methods as in Chapter 7. So one method is to use your graphing calculator. Just like in Chapter 7, you would either use NCD or normal CDF. And also like before, it helps to draw out a normal curve first. So we know that our curve is normally distributed. We've already kind of drawn it out in part A, but I'm going to redraw it over here. The mean is 120. And we want to find the probability that a sample mean would be less than 112. So I'm going to put, so 112 is somewhere below it, somewhere down here. And we want to find this area under the curve. So this would give us the probability of getting a sample mean of less than 112. And to find that on the Casio calculator, again, it's all the same steps as you did in Chapter 7. For the lower bound, we'd put negative 10 to the 99 because the left boundary is negative infinity, just goes forever towards negative infinity. The right boundary is 112, so that's the upper bound. The standard deviation is 5.5. Remember that we had to do a separate calculation to find standard deviation in part A. So 5.5, and then the mean is still 120. Same thing on the TI calculators, all the same steps as in Chapter 7. You would use normal CDF. Negative 10 to the 99 is the lower, 112 is the upper, 120 is the mean, 5.5 is the standard deviation. When you plug those all in, your results should be about 0.0729. The other way to solve this is to use the normal probability table, or Table 5. And again, if you're using Table 5, it still helps to draw out that normal curve. And I'll just quickly redraw this again. We're trying to find the area of that side of the curve. The next thing is calculate the z-scores. Use the z-score formula. The formula, it looks a little different, but it's pretty much the same formula as what was in Chapter 7. The only difference is that now everything is in terms of x bar, in terms of the sample mean. So our sample mean is the upper boundary, 112. The population, or I'm sorry, the mean of the sample means is 120, and the standard deviation of the sample means is 5.5. Plug those all in, and you'll get about negative 1.45. So remember that all that you've really done is you've converted your probability so that it's no longer in terms of x bar, it's now just in terms of z. And that means that you can go to table 5, go to the normal distribution table, and look up that z value. So we want the z of negative 1.45. So here's negative 1.4, and then here's the 5. They line up to about right here. Negative 1.4, and here's the 5. So 0.0735. And that's the probability, because that is representing the area to the left of negative 1.45. And just like in chapter 7, it's just good to note that when we use the calculator, this was our result, negative 0.0729. When using the table, we got 0.0735. So there's that slight difference, but that difference is okay. It's just due to the fact that when using the table, we had to round off our z-score. Now we'll move on to part C. Part C is what is the probability that a random sample of 16 bagels results in a sample mean of more than 133 grams. So we're trying to find this probability. Again, the ways that we'll solve this are going to be just the same as what you did in chapter 7. We could use a graphing calculator as one method. We'll use NCD, or normal CDF, on the TI-83 or on the Casio. I'll start off by drawing out the curve. So 120 is still the mean, and 133 is somewhere above it, so it's up here. And we want to find the probability of a sample mean of 120 or more. So that means that, 133 or more. So 133 is our lower bound this time, and our upper bound, the right boundary, is infinity. It goes forever towards infinity. So on the Casio, take those steps, get to NCD. Your lower is 133, upper is the infinity. Put in the standard deviation, the mean. That will give you the result. Similar on the TI-83 and 84, use normal CDF. Put in all of these numbers, and the result should come out to about 0.009. So the other way to work this out is to use the table 5. And again, if you were doing it this way, it still helps to draw out that curve. We want to calculate the z-score using that z-score formula. This time our x bar is 133. Plug in all the numbers and we'll get 2.36. And so now we have converted our probability so that it's no longer in terms of the sample mean, but just in terms of z. And that means that now we can go right to table 5, use table 5, and we're looking for a z of 2.36. So we'll go down here, look for a 2.36. Here's 2.3, and the 6 is up here. So line up where those are at. Looks like they line up right here, 0.9909. But again, you want to remember that that 0.9909, that represents the area to the curve to the left of 2.36. So up here, if the z is 2.36, that 0.9909 represents the area on this side. But for this probability, we're looking for the area to the right, for everything that's above 133. And that area on the right is going to be the complement. So we'll do 1 minus 0.9909, which is 0.0091. So we find that complement, 1 minus 0.9909, it's 0.0091. And so that's our probability. And again, we got slightly different results between using the calculator and the table, but that's okay. You'll get slightly different results. All right, in the next video, we'll take a look at a second example.